Thanks, Laura, and this should square us for that wonderful introduction.
The book's $17.50 on Amazon.
Let me add my welcome to Laura's, because I do believe strongly that a fundamental part of what we're trying to do with a mission like MAVEN is to do cool things, but then to communicate it to the public. And you guys are a big way that we do that. And that's why a workshop like this is part of the education and public outreach program of MAVEN. I am a big believer in the EPO program and in doing things like this. So thank you all for coming and taking your weekend, especially on what I didn't realize until a day or two ago was Father's Day weekend. I know that that's a hardship on many of you, and I very much appreciate it. What I want to do tonight, tomorrow I'm going to talk about the science of MAVEN, and tonight, trying to figure out what to talk about, I thought I would talk about the implementation of MAVEN, a little bit of the history. And really what I'm going to do is tell you some of the stories that we tell sitting around in the bar at night with a couple of drinks. So please go help yourself to some more wine. I hope I've put together some interesting stories, and we will find out. This is a new kind of talk for me. I've never done this before, and you can give me feedback afterwards as to whether it was too Bruce-centric or too personal or too annoying. And I'm sure Laura will give me all kinds of feedback on all of the above. So what I want to do is just walk through some of the things that went on with MAVEN. And you saw the charts that they had looping through ahead of time. And I wanted to start with the launch because it's an incredibly emotional moment. Today we are 12 years after what I consider the start of MAVEN, and I'll talk about that. Launch was 10 years after the start, and we got selected on our first proposal. So it was about as quickly as you can go from a concept to a launch. The launch is really a turning point in the mission because it's the last point that you have any chance to influence the hardware, for good, bad, or otherwise. And after that, it's only what you can do from the ground. We had something like 13,000 people out at the Cape to watch it, total, which is the most they've ever had for a planetary mission. And I'm told it puts it up in the realm of some of the high-end shuttle mission launches in terms of number of people. Among them was my wife, who was out on the causeway watching this, going, "Oh my God, how are we going to console him tonight when the thing blows up on the launch pad?" Because I had spent the last 10 years worrying about that. And she came in one day and saw me reading a book that some of you have probably seen called Space Mission Failures, or something like that. And it goes through every US mission that failed and describes it and what happened. And it's incredibly instructive to go through that. But apparently I paid a little too much attention to that because she really thought it was going to blow up. Needless to say, we had a spectacular party that night for the 200 people we had down at the launch. When I was in the control room at the time, and we'd gone through rehearsals, 3 or 4 or 5 rehearsals. We'd done a lot of what-ifs. The countdown was perfectly smooth. A couple of minor hiccups, nothing that came anywhere near possibly causing a delay. But I remember when we had the go for launch to end the T-4 minute launch hold. It's like, okay, here we go. And I couldn't sit there at the console. I had to stand up. And as soon as I did, I realized why there's a bar across the top of the console. It's something to grab onto and hold onto. It was probably the most nerve-wracking half hour or 45 minutes from that point to solar panels are deployed, it's on its way, and we have positive power. And it was exacerbated by the fact that once it deploys the solar panels, it looks for the sun. And it's got a couple of different algorithms. The first algorithm it went the wrong way. And eventually realized and turned around and went the right way. It's how it's supposed to work, because you have no idea what configuration what orientation it's going to come off in. But that meant it took about an extra 15 minutes before we had solar panels on the sun, confirmation that we had power and that everything had deployed.
We were watching it here, and the media was apparently really disappointed that as soon as it reached zero and took off, that people were like, good, good so far. They thought we would jump up and...
Oh, I did. One of the funny things, you learn things that you would never have known. For example, it does not lift off at t equals 0. It lifts off at t equals plus 0.3 seconds or 0.27 seconds. And it took me the longest time to find out what happens at t equals 0. And that's when ignition is at t minus 2.7 seconds. But at t equals 0, that's when they are committed to going. Up until that point, they can shut the engines down if there's a problem. At 0, they can't. They release the clamps, and then it lifts off a third of a second later. So it looks like it takes forever to get up, but it doesn't. I wanted to go back to what I consider to be day one of MAVEN. And I didn't have a good picture, but this is my car. Can you guess that it's dominating my life? Day one, in my mind, is a conversation that I had with Bob Lynn and Janet Lumen here at SSL. Bob has since passed away and didn't make it to the launch. But we had an hour-long phone call back in the fall of 2003 discussing whether a mission like MAVEN had a chance of being competitive. We knew that NASA was going to have an opportunity to propose a Mars Scout mission coming up in the next couple of years. And we thought that this was first-rate science, to explore the upper atmosphere, to look at the evolution, loss of gas to space, evolution of the climate. But we didn't know if we could sell it. And to give you an example, one of my colleagues who was in a senior position within NASA, and I'm not going to name him, I was talking with him about this mission, and he said, why would we ever want to fly an Aeronomy mission if we could fly another rover? And that's the attitude that we had to fight, that geology is really at the center of Mars exploration, because it is in so many ways. And to do an upper atmosphere mission really is going against the grain. A mission like MAVEN goes back in concept for Mars to 1986 with a report recommending that. And if you look back at what they recommended, our mission looks almost exactly like what they suggested. We invented it from scratch. And we take full credit for it, but it just looked like what had been recommended for decades. But at the end of that phone call, the three of us thought that first, this had a chance of getting selected. Second, that a collaboration between the Space Sciences Lab here at Berkeley and my lab, which is Laboratory for Atmospheric and Space Physics at Colorado, would really form an incredibly strong backbone of the science team. And third, that the collaboration and the science were more important than who was going to be the PI. Bob and I agreed that one of us would be the PI, but it didn't matter which. And we would push that off to another day. It turns out, I found out later, Bob really wanted me to be the PI because they wanted a Mars guy to front for it. And I wanted to be PI too. So it worked out. But on day one, it wasn't as important as the science and the collaboration. This is a photo from one of our first science team meetings where we have all the key players. I see we already have name tags with the logo on them. So this was relatively late in the process. The first couple of years, we're assembling the team. And from that first conversation of 3 people, Bob went off and looked at what instruments coming out of SSL would make sense. I looked at what instruments coming out of Colorado. And 6 of the 8 instruments come out of one of those 2 institutions. But we also had to, we'll provide these charts for you. You don't need to shoot pictures of them. We'll provide, God, that's what I just said. This is what I get for having a glass of wine before giving a talk. I'm probably going to say a lot of things I regret saying. We needed to, once we had a science concept and the instruments, which we worked on as a team for a couple of years putting together, we needed two other key components. One was a spacecraft contractor, and the other was a NASA Center partner to provide project management. I was going to go talk to all of the spacecraft contractors. I started with Lockheed Martin just because I happened to know the people there, and they were very convenient to me up in Boulder. And it's a bit of a dance. We went down and talked with them, and we want to partner with them but don't want to commit because we're going to talk to others. They want to partner with us but don't want to commit because they've got to pick and choose who they're going to partner with. So it's this bizarre dance of trying to court somebody but not quite being ready to commit. And on the drive back, I remember saying that if they didn't want to partner with us, I didn't want to do the mission because they had so much experience with this type of a mission, in this type of an orbit with all the aerobraking on earlier missions, that I didn't think anybody could compete with that. The NASA Center partner, we looked at JPL, NASA Ames, APL, and Goddard. And I spoke with people from all of them. And in the end, I thought Goddard was the most forward-looking and science-oriented center. And it meshed incredibly well with the science we wanted to do. Not to mention the fact that we had two instruments by that time that were going to come from Goddard, and it would make it that much easier. I approached Ed Weiler, who was the center director, to see if they wanted to partner with us, and got back and absolutely, and got in touch with the right people, and it moved very smoothly forward from that. If you look here, you see a lot of Goddard people, a lot of Lockheed people. I owe a lot to Bob Bartlett, who was with the project almost from day one, Bill Cutlip, who saw us through the proposal stages and guided us from the new business perspective. I understand what new business opportunities are now. And it's interesting, in the four corners of the picture are four Lockheed guys, and they really are the cornerstone of doing a mission like this. So we spent 3 years putting together the original proposal. We were selected, and along with one other team, to do a Phase A study. And you can see here on the left, we've just finished assembling all of the hard copies of the concept study report. The original proposal was about this thick. The concept study report is about this thick and represents a year of effort. And then on the right, we're delivering it to NASA headquarters. Since it came from Goddard, it was just driven down in a van. But you look at these boxes and you look at the size of that. Each box, I think, had 3 copies in it, and we had to deliver 50 copies. What I think was interesting is, if you look at the effort that went into the original proposal, and some of it was paid for by institutional funds, some of it was done on nights and weekends, or I'll deny this if I'm ever asked, and I will claim that Tom doctored the video by charging it against another contract. But I tried to add up at the time how much effort actually went in. And my best estimate was that it took $2 to $3 million of somebody's money and effort to produce a proposal. And there were 20 proposals to that Mars Scout opportunity. So that's a fair amount of money that it took to run a competition. They selected 2 teams and gave us each, I think it was $2 million. And each of the, I don't know what the other team did, but I know we put in about another $1 million of our own money to do the Phase A study. And that was 9 months. I think it's money well spent because we were so competitive that we wanted to make sure we had everything done right. We wanted to make sure we had the best science, the best engineering, because we were going to have to compete against people who were really good. And I think that $60 or $70 million of somebody's money is incredibly well spent with the end product you have. There was a hitch. By the way, if you want to interrupt with questions.
Did anybody else propose an aeronomy mission?
There were 2 aeronomy missions proposed, and they were the 2 that were selected for Phase A study. And I don't fully understand the politics of why they did it that way, except certainly that allowed them to know that they were going to select an aeronomy mission because they couldn't imagine that both of them would fail. That meant they could check the box and go on to do something else. I have not delved too much into the other proposal, other than the rumors you hear. You know, we heard that their team was imploding. They heard that our team was imploding. All the sorts of rumors. And what I believe is that they had very similar science concepts to us, different implementation because it had different history, different people playing a role. We got down to the site visit. The way they do this, you run you do the concept study report for 9 months, you turn in the big thick volume, they have a review panel that evaluates it, and then they ask us questions, and we have a 1-day site visit in front of a review panel. Our site visit that year, it was 2006, was going to be on December 4th, and if you backed up, we needed 10 days to run up because they were going to send us questions. We had a week to work the questions. We needed to put our presentations together. We had 25 people that were going to travel to Lockheed Martin to be in residence there for those 10 days. And they were all going to travel on Sunday of Thanksgiving weekend. This is probably my favorite story of all of MAVEN. So I went to the West Coast with my family for Thanksgiving. I was going to fly back a day and a half early in order to go down to Lockheed. And I'm sitting in a restaurant with my family on Wednesday afternoon, West Coast, noon Western, Pacific. And I get a call from Michael Meyer, who's the lead Mars scientist at headquarters. He goes, "Bruce, have you seen your email today?" And I go, "No." He goes, "Well, I got to tell you, the site visit is postponed." And apparently, my wife said I just sat there at the table going, "You're kidding, you're kidding." But they had discovered a conflict of interest on the review panel, I'm told, and they couldn't resolve it, so they had to postpone the site visit. Bless Michael Meyer for calling me and giving a heads up. I called our project manager, and he got the word out. I go, "Dave, are you sitting down?" He got the word out to everybody with emails, phone calls, office visits, all except one guy, and I've deleted his name from this copy of the email. He had already left for Thanksgiving and didn't check email or voicemail till he was in his hotel in Denver on Sunday night. He tells the story. He pulls up to the hotel. Parking lot is empty. What do you expect, Sunday of Thanksgiving weekend? He goes inside to check in. "Is anybody from our group here?" "No." So he goes in and looks at his email, and we get this from him. "OMG, what do I do now?" He had not seen the message. He turned around and flew back the next morning, hoping he would get reimbursed, which he did. But the funny part is, I didn't hear this until several years later. His wife had been giving him a hard time, saying, "You know, you're always checking email and voicemail. This is Thanksgiving. We have family in from out of town. Can you let it go just this once?" And I think if there was ever an "I told you so."
I want to know how you got someone to reimburse him.
He had travel orders. Even though they were canceled, he never got the word.
Okay.
The government will, as bizarre as government travel rules are, they will reimburse you in a case like that.
States, not so much.
So we finally, we had to do a do-over on it because they decided that by the time they could reconstitute a review panel, we would have lost so much time it wouldn't have been possible to, for whoever won the competition, to be ready for a 2011 launch. So they delayed to 2013. It's a different opportunity. You need to do the study again. So they gave us another $1 million and 4 months this time and said, "Do it again." Man, what fun. So we had the same thing. We all went down and camped at the hotel, and we took over the breakfast room to do the preparations. We had the site visit. We were told no cameras allowed, but one of our people sitting in the back row surreptitiously took this photo while we were milling around before it started. And I'll tell you, I was so busy schmoozing with the people I knew, some of whom were on the review panel, I almost forgot to start on time. And then afterwards, we had a 30-minute presentation to the selecting official, and that was at NASA headquarters, and I was invited with 4 of my best friends to come down and present. That's Dave Mitchell on the far right, who is the project manager. He's the one who saw us through development. Bob Lynn, who was the deputy PI, me, Ed Setovy, who was the Lockheed project manager, program manager in charge of the spacecraft, and then Dave Mitchell on the left from SSL here, who was there for science. We tried to have somebody to represent any areas we might get questioned on. And you notice we have 2 Dave Mitchells. Dave Mitchell, the scientist on the left, also known as California Dave, and Dave Mitchell, the manager on the right, known as East Coast Dave. One thing I learned on a project like this, redundancy. We had 2 Dave Mitchells, we had 2 Mike McGraths, one at Goddard, one at LASP. We had, the one that gets me is all the Tims we had. We had Tim Holbrook, Tim Prizer, Tim Bowser, Tim Gasparini, Tim Trinkle, and then they threw at me that when you have a meeting, it's a technical interchange meeting. Tim.
There's 2 Tims here.
You can't get away from them.
Is that Jim Green?
No. Which one?
Top picture in the back on the left.
No, that's Tim Trinkle. He was at that time our mission systems engineer. He's now like the number 2 engineer at Goddard. I forget what his exact title is. And Dave Mitchell, who is our project manager, he rotated off of MAVEN after we started Science Ops and got 2 promotions since then. He's now the director of flight programs at Goddard, so 1 step below the center director. I got a call then from Michael Meyer again to tell me we'd been selected, and we had a press conference the day we got selected. But he calls me up, and I was in a meeting in somebody's office, and I immediately walked out without saying a word. We were expecting a call one way or the other, and I could see who it was on my cell phone. And I pick up the phone. He goes, "How are you, Bruce?" I go, "You tell me." And he still wouldn't say anything. He goes, "What are you doing next week?" And he wanted me to go to the MEPAG meeting and brief everybody about MAVEN because we were selected. So he's a smart ass. What can I say? Most of what I remember from the development stage is reviews. This is one of them, and it only bothers me a little bit that everybody on the review panel is sitting there looking at their laptop. It was actually an outstanding review panel. We tried to count up as accurately as possible 220 reviews from concept to launch. And that includes big reviews like launch readiness review a couple of days before launch, critical design review for the project, preliminary design review, but all the way down to peer reviews for the instruments. And some of the instruments would have 10 peer reviews. So we had 220 reviews. We had a contest just before launch to see who had been to the most, and I put a bottle of scotch in as the prize. I only went to 75 of those, plus or minus a couple. Dave Mitchell only went to 75. Bob Bartlett, who I pointed out in that team picture, went to 95. And so he won the bottle of scotch. Once we were, let's see. One of the fun things of being PI is you get to do some cool things. And one of them was during the middle of assembly, taking my family down, and we all went into the clean room. And Jim Brantley, who was the floor manager for assembly, took 45 minutes out to walk us all around the spacecraft. That's me in the middle, and then going to my right, my wife, my stepson, and then the other direction, my stepdaughter and her boyfriend. My wife is just eyes agog at this. I get very blasé, but when I see her eyes get wide like that, it reminds me this really is a cool thing to do. And it's actually a lot of fun to be able to go down and bunny suit up and go in and look at the stuff, at the hardware close up that you know is going to Mars. That's a rare opportunity. So once it was, I'm not going to go through the details of assembly and testing, but I do want to mention this, and that's shipped to the Cape. Stephen, I realize you're in this picture in the upper left. This was the day it got shipped down to the Cape, put in the box, pulling out of the garage, shipped to by truck to Buckley Air Force Base, loaded into the back of a C-17, flown with some of us on board, which again is a really cool thing to do. That's again one of the perks. You get to say, I'm going to fly on that, and they let you. Landing at the shuttle landing strip after a long day, and then it was carted off, put onto a truck, and put into the hazardous spacecraft facility, the clean room where it was handled down there. And I realized watching this, and really when I took that picture at the front, that it's like when you take a vacation with your family. The vacation doesn't start when you go out onto the beach in Hawaii. It starts when you get in the car and pull out of the garage at home. And that's what happened. This is the first step in the trip to Mars. Putting it in the car and trucking it to the airport and flying on the first route. So for me, it was a very emotional moment. Pictures of MAVEN's launch vehicle as it arrived at the Cape. And again, this thing with the payload fairing, we'd spent a lot of time talking about what our payload, what our logo would be on the side of the fairing. We wanted to use the logo that is our standard logo that was on the cover chart, but they said that's too complicated, you can't use that. And we came up with this one, which they would let us use. Again, for me, it was a very emotional moment seeing the fairing for the first time with our logo on it. You know, it's like, wow, this really is real. MAVEN is not just a bunch of view graphs and 220 reviews, but it's the hardware. And I go back, I think I can trace my interest in space back to being a 6-year-old watching the countdown of the first Mercury launches. And you know, to me, it is just so exciting to be able to do this. And it's so exciting talking to the people who are working on it, because this is the coolest thing they could think they're doing. Once it was down at the Cape, all of our meetings shifted to there, reviews, TIMs, etc. And we did the same things everyone else does. You play tourist and get to go around and see the things. This was looking at one of the Atlas V's, not ours, but one about 6 months before us. And so we did the usual thing of having our picture taken in front of it. This is standing up at the top of the vertical integration facility where our rocket would be, looking out at the launch pad.
Bruce, I wanted to point out something about the fairing. A lot of people may not know that's hand-painted. The logo is hand-painted.
That is true. And there's somebody whose job is to hand-paint those. And there's another story I heard, I think it was with the Phoenix lander, that they got out onto the pad and realized there was a typo on the fairing. And they sent somebody out there to go up there and hand paint it and correct it.
Let's be fair, Phoenix is a hard word to spell.
Is it a special kind of paint that's very...
I don't know. But it's hand-painted because you can see, if you go back to the fairing photo, has those ridges.
yeah.
So decals won't work.
Yeah.
A lot of other rockets use decals, but that specific fairing, they have to hand paint it.
As soon as we started talking launch vehicle, we understood we had a 10 by 10 foot area to do with what we wanted, as long as the guy could paint it. And the number of hours, it's the same thing like when you come up with the name of a mission. It's the most important decision you're going to make, and you want it to be right. With the name of the mission, you know, we sat in a bar, of course, and people threw out names. and there was a lot of email traffic as to what the name should be. And I've looked and looked in my email, and I've lost it. But I wish I had the suggestions that other people made, because they were so bad. You would not believe how bad a name people came up with. You know, I've taken a lot of grief from MAVEN because it's not a true acronym. The N at the end of MAVEN is the N at the end of evolution. So people give me grief over that. And my response is, you should have seen the ones we didn't use.
It's pretty good.
The funny thing, you know, since launch, 2 different people have come up to me and said, did you know that MAVEN is actually a word? And it means something? It's like, I'm not stupid. So I have one of the more bizarre stories that I want to tell. And that is, you guys remember the government shutdown 6 weeks prior to our launch. The government was shut down for 17 days. If we had been shut down for 17 days, we probably would have missed our launch window. We could take a few days. We were on schedule. We had a couple of days of margin. And in the end, we were shut down for 2 days, and we were able to make that up over the next couple of weeks without any difficulty. So we were still ready to go on day 1. During the shutdown, government workers couldn't work. Contractors could work as long as they had funds on the contract. So Lockheed could continue to go, Colorado could continue, but we were working at Kennedy Space Center, and rather on the Cape Canaveral side, and they were shut down. So we had to shut down. People who could would sit in their hotel rooms and work. Lockheed has a facility. People would go there and do the paperwork. But there was no work on the spacecraft. After 2 days, they started us back up. And the argument, legally, I forget the name of the law, but legally, the only reason anybody could work on government contract for government workers was to protect lives or property. The fact that we would miss our launch window doesn't matter at all. They wouldn't have started us back up for that. But somebody put forward the argument that by launching us, we were protecting the Curiosity rover because we were the backup communications relay. I remember participating in writing the legal brief. I'm not a lawyer, but I still wrote some of the words in it to justify it. And I know it went up through the Goddard chain. So to the Goddard Center Director and Chief Legal Counsel, the NASA Administrator and Chief Legal Counsel, and then up above there, I don't get any insight into it, but it either went to the White House or OMB to approve it. And it was approved, and we were started back up. That was, by the way, when I learned the power of social media, because we had a telecon to let everybody on the team know we were starting up and how we were going to do it and what the schedule for the next 36 hours was. And within an hour after that, I was getting phone calls because one of our team members posted on his Facebook site, I guess I get to go back to work. And that was all he put. But one of his friends was a reporter in the business. And I started getting calls from her, is MAVEN started back up? Are you back to work? And it took us the better part of a day. We had to put together talking points and make sure we weren't going to say anything stupid and then get it out to people. But I learned, A, social media is incredibly powerful, and B, no matter what you do, you can't bottle it up. You can't keep people from talking. So you just have to learn to live with it. As an aside, there was the possibility that if we did stay shut down, we would miss our launch period. We would have to wait 2 years. If we did have to, this is going to come up again too, but if we did have to wait 2 years, we couldn't have done our mission because the opportunity with an early 2016 launch was more difficult. It would have taken more fuel to get into orbit, and we couldn't even have gotten our orbit down to our primary science orbit, let alone do the mission. So it's really a good thing we got off on time. As an aside, it was also my best line ever. I was doing an interview with a reporter from NPR, Jeff Broomfield, and I went and did it in his office because I happened to be in Washington at the time, did it in their studio. And he talked with me, interviewed me for about a half an hour, and he used about 20 seconds of it. And at one point I had said that there was a camera in the clean room so that people who weren't located on site could watch and see what activities were taking place. And so he asked me if I kept going to the website and clicking on that link to make sure the spacecraft was okay. And I said, no, I kept going to the CNN website to see if Congress had done anything. And that was the line he used. Out of the whole half hour, that was the quote. I wanted to put up the team during launch week. You saw some pictures like this during the slides that were running ahead of time. We were all down there for the launch, of course. We were out there. This was on Sunday afternoon, the day before launch, just as the sun was starting to set. It took us that long to get out there. The slides that Chris had running ahead of time said Sunday was a crew rest day, and so everyone was supposed to be off. I was working from 8 in the morning, from 7 in the morning till after this, which ended at about 6 at night, just running around constantly. And I almost ran out of gas because I couldn't get off anywhere to fill my car up. And so I took a few minutes, and I was afraid driving off of KSC, it's about 10 miles to the nearest gas station. I wasn't sure I was going to make it. Not everybody was on site. We had a team at Denver because the instant it lifts off, control shifts from Kennedy to Denver. So we had a complete duplicate of the team and all the facilities there so they could take over. The NAV group, the Deep Space Operations Center at JPL, and those poor guys in the ops team at Denver. The ops team never gets to see launches because they're always on console, either back in Denver or at Kennedy. So it turns out that the group at Kennedy, once the countdown reaches T-minus 15 seconds, they can't do anything. They can call a hold up until T-minus 10 seconds, but the guys on console for the spacecraft, they have to relay it to the project manager in the blockhouse, who relays it to the launch mission director, to the launch director. So after about T-minus 15 seconds, he can't do anything. So they had all agreed that at T-minus 15, they would all take off their headsets, put them down, and run outside so they could watch it. And so one of the guys said, should we rehearse? We're doing all these other rehearsals. Should we rehearse running outside? And everyone laughed at him, but then during the real thing, it was like the Three Stooges. They all got bunched up in the door. So I'm not going to go through this. I just needed a transition slide. We launched. We had a 10-month cruise, orbit insertion with a powered burn, and we're in the middle of our 1 year of science ops. When we got to Mars, we have Mars orbit insertion. That's a 33-minute burn of the rocket on the spacecraft. And if that doesn't go right, we're done. And that's fully autonomous because it was about a 12-minute one-way light time. So by the time we saw the start of the burn, it was almost over. And we couldn't send a command. We had gone through rehearsals. You know, what are we doing on the days up to it? What are we doing if there's a problem? This is the control room at Lockheed Martin. There are 6 bays there with consoles on 3 sides. This was during the middle of the burn, and everybody's watching one of the big consoles on the wall. We were still trying to figure out what it was we were going to see that would tell us it had gone into orbit. And in the end, we were watching the Doppler shift signal on the radio transmission. The way MAVEN works, it's got a fixed high gain antenna. So the high gain wasn't pointed at Earth, but the low gain would send a signal at 10 bits per second or something like that. And the data it was sending was useless, but the carrier signal, the frequency, would tell us the speed in the line of sight. And so it was plotted against a model that showed what we expected it to be. And at about the right time, the Doppler shift went from, let's see, what did it do? It went from the difference from the model went from that to a sudden jump, and we knew that that was it. And then about Dave Folta, the nav lead, he had told us that it might be as much as 5 minutes of analysis before they knew if it was in orbit. But about 20 seconds after we saw the signal, he came on with the announcement over the monitors that we were in orbit, and that's when everybody erupted in applause. It took us 6 hours to confirm that we were in orbit and to determine our orbit and start getting ready for the first maneuver. But that was the key signal. Again, it worked perfectly, just right down the middle.
Who was in charge of metric English conversion?
That's cruel.
You're that kid, huh?
So one
Note
thing
to self, don't talk to Kelly anymore.
one thing you've so far left out of the story is that comet that lots of rumors said was going to destroy. Oh, okay, sorry.
This is time sequential. Comet sighting spring got to Mars 4 weeks after we did, give or take a day. And it had been discovered early in 2013. Initially, as you were about to say, people thought it might have been on a collision course. It passed 130,000 or 140,000 kilometers from Mars. On the right, this is a Lyman alpha image of the comet taken by MAVEN 2 days before closest approach. And what is interesting is if you mark off 140,000 kilometers from the center, puts you out about there, you're still within all the debris. So when we saw this image, we knew that Mars and the spacecraft were going to get hit with stuff. It was just a matter of how much. When it was discovered, we had serious discussion of what do we do? And we debated options, including adding more shielding, take the blanketing and doubling it to give us more protection. The most extreme was not launching. If we really believed we would get killed, it would be silly to launch, and we would wait 2 years. If it had been on a collision course, I would have chosen not to launch, because a collision of a good-sized comet would send enough debris up that it would have killed us, without any doubt. We decided in the end we would do what the engineers were most comfortable with, and that was don't make any last-minute changes and do anything stupid. The problem with adding more layers as shielding was that actually makes it worse, because it's more things that it can hit, and it breaks the pieces up into more pieces. So it increases the risk of damage. We decided to take our chances. What we could do, we did what we could do, and that was we phased our timing within the orbit so that at the time at which there would be the peak risk from dust based on the models of how dust moves away from a comet, we would be shielded by the planet. We could get, I think it was 22 minutes of shielding out of about a 30-minute period when we thought the most dust would be coming in. We also turned our solar panels edge on to the flow, give us the minimum cross-sectional area. We turned off the high voltage on everything. That impacted most particularly the instruments. Some of the guys are still ticked at me for not letting them have their instruments on, but high voltage was off. They had to, in order to stay on during the encounter, they had to convince me that if they got hit while they were on, the damage would be no worse than if they had been turned off. And for all the instruments that didn't have high voltage, that was easy. But those that did, that just makes it worse. We went into what we called hunker down mode. By the way, if you look up hunker down on the web to find out the definition, it turns out that the leading definition is that it is a game played when hurricanes are coming. You turn on the news, and every time the weatherman says hunker down, you take a shot. That was our approach on MAVEN. We went into hunker down mode about an hour before we thought there was any risk, and we stayed in it for an hour after. Once the risk was over, we commanded the spacecraft to reorient back to Earth so that we could downlink data. We looked at enough spacecraft data to convince ourselves that the spacecraft had no damage, and then we could turn on the instruments, turn on the high voltage. We did that. We downlinked enough data to convince ourselves that the instruments had suffered no damage, because what we wanted to do was to see if there was any effect at Mars, and we needed to turn the instruments on as quickly as we could. The Lockheed Martin and spacecraft instrument ops team went through that whole process inside of one orbit. So it took about 3.5 or 4 hours, and we were turned on when we went through that first periapsis pass after the peak risk. And I'm going to talk about the science tomorrow, but we saw some really cool things that I want to tell you about.
Excuse me, Bruce, maybe you'll touch on this tomorrow, but were you tempted to leave the mass spec on because you're flying through a comet's coma and you have a mass spec?
No. Because MAVEN is not a Comet mission. We had this discussion ad nauseum of, we can do so much cool science, but we want to survive to do the Mars science. This was in the middle of commissioning. We did take a week out of our commissioning, even though we weren't quite ready, to do some observations of Mars before, some observations of the comet, go into hunker down mode, come back, and do a couple more days of observations of Mars. We oriented, in addition to orienting the spacecraft, the mass spec, the ultraviolet instrument, and an instrument called STATIC are all on a 2-axis gimbaled articulated payload platform, and we oriented that in a way so that none of the apertures were pointed into the flow. We oriented the spacecraft so that the star trackers were not pointed into the flow. It was, in my mind, all about risk mitigation to survive, because we didn't know what the flux of particles would be. I did the calculation. The comet dust, the comet, was moving relative to the spacecraft into Mars with a speed of 56 kilometers per second. So dust that comes off of the comet only moves away from the comet at a few meters per second. So any dust that hit us would come in at 56 kilometers per second. You take a tiny grain of dust, 20 microns across, and move it at 56 kilometers per second. It has the same kinetic energy as a .30 caliber bullet shot out of a pistol. So yes, I'm going to walk up to the aperture of the Engels instrument, point a pistol at it, and shoot into the aperture. This was not a hard decision. Not after working 10 years to get there. And $600 million, well, by that time we'd only spent $570 million, whatever. Even though there's good science, I wasn't going to risk it. Now, Roger Yell, one of our science team members, said that taking MAVEN and flying it to a comet like this would be a first-rate Discovery class mission. And he convinced us that it was worth taking a week out and observing it and doing what we could. And that was well worth it. It really torqued the team because it was right in the middle of the most intense period trying to commission the spacecraft. But we got some really cool stuff. The Lyman Alpha image, paper on this is just going in now. The observations of Mars after the dust hit it, those papers were, what's the date today? Are we on like 19? They just appeared this week in Geophysical Research Letters. Really cool stuff, but not what we started out for. So I've got just a couple more charts here that I want to show. And the first is, Laura talked about the book I'd written and the societal impact. And one of the things that impresses me is how many people are really interested in Mars exploration. And the fact we've got, I forget the exact numbers, Laura, you probably know them, or Tom. I think we have 30,000 Facebook followers, 75,000 Twitter followers. And these are the people that just want to know and can't wait to hear the next thing about Mars. And there are people that you wouldn't think would get excited that really do. On the left, this is a second grader whose parents did sign a release form, by the way, who on her own built a Halloween costume last year for MAVEN. And that is just the cutest picture. People are excited. I get emails, not daily, but I would say every other week, from someone from around the country doing a middle school project on MAVEN, or wanting to know more about MAVEN. The one on the right was when a classroom visited LASP, and we were demonstrating how to bunny suit up and go into the clean room, and this poor little kid just got, even though you can't recognize him, we have a signed release from his parents too. It's really fun to be able to do something that people think is exciting. I think it is. Dave does, Laura does, I think you guys do, or you wouldn't be here. But it amazes me that the real world does too. The last thing, this is my last chart. As PI of the mission, I've put a dozen years of my life into it, and it really is an incredible responsibility to have the trust of NASA to run a mission. They provide a lot of oversight, so it's not just, here's a check, go off and do it. But it's an incredible responsibility to make sure it's done right, but it's an incredible opportunity to be able to shape a mission, to focus on the science that I think is important, and to do what I think is necessary to have it come off successfully. It is such an incredible opportunity. I don't think I could do it a second time. I don't have the heart to invest in it a second time. But man, what a ride. And I look back at my career so far, and this is such an exciting thing to do. I can't imagine turning down an opportunity to lead a mission like this. So I will stop there, but if you guys have any questions, I'll be glad to talk about them. On anything but science, science we'll cover tomorrow. Yes?
So did you do the hunker down drinking game as you were hunkering down?
No comment.
I was going to say the only image that got into my head is you guys waiting. Yeah.
Well, it would have happened during all of our reviews because we talked about hunker down mode. That was our formal name for it.
Right, okay.
So there's a new trend in trailers of movies to list all of the babies that were born during the production. Did you do anything like that?
Our deputy project manager for resources, Susan Sparacino, who was in some of these pictures and who is retiring from NASA at the end of this month after a long and incredible career as a resource manager, is very into that. And we have a complete listing of all the babies born. And at meetings, we usually have slides rolling like the slides that were running before this talk that show the pictures of the babies. Do you know the number?
I don't know the number, but my son is the oldest, as far as we know. Which means I've been working on MAVEN longer than I have had children, which is a very scary thought.
I have too, but that's only because I didn't marry into my family until after I started MAVEN. I would say we have probably around 75 MAVEN babies. Okay, now let's see if I can do this right. One of the people that works for Design America, which is the group responsible for our ground computer system, named their daughter MAVEN.
I was going to ask that, but I was also thinking like names you could get out of the letters, like Evan or Neva.
Navum.
That would be the one.
Yeah, I actually thought that was way too invested when you were showing a picture of your car. I'm like, well, if you named your kid Maven, then maybe you could do that.
I won't show you the Maven tattoo. It's a big enough deal to put it on your license plate. Boulder's a small town. Everybody then knows who I am. I had to start keeping my car clean. I had to drive courteously. I had to stop parking in front of the strip joints.
There's strip joints. I never saw them.
I'll tell you where they are.
So you said at the end that it's an incredible opportunity, an incredible responsibility. You kind of hinted that I'm really glad I did it, but I don't want to do it again.
Absolutely, no way in hell.
Take too much out of you, or what? You put your scientific career on hold.
No, this is my scientific career. I realized what had happened many times, but an example is earlier this week I went to NASA Ames to participate in a PI training course that they're running for their future mission PIs. And I looked around the room and there were 4 PIs in the room who had experience. 3 of them were wearing ties. None of the other people in the room were wearing ties, even the managers. I'm a manager. I'm not an active scientist. But this is my scientific career. I don't have any regrets about that. I don't get to look at MAVEN data. I'm so busy worrying about ops and funding and budgets and stuff like that. But that doesn't change my mind. This is such a cool thing to do. But you put your heart and soul into it for a decade, and it would be hard to go back to square one and do that again, knowing the commitment that was coming ahead. I didn't have a clue what I was getting into when I started this. And it could have gone either way. It could have been complete drudgery. All the stuff you have to do are really fun. And I lucked out. It was really fun. The whole thing. Well, except for about there are 3 or 4 days in there that weren't a lot of fun.
75 reviews.
Yeah.
The reviews were actually interesting. The not so fun days were the days we had to descope instruments because we needed to cut $25 million off of the budget. The day we had to make a decision 2 months before launch, do we take one of the instruments off the spacecraft and ship it home to be ripped apart because it was doing some anomalous things? That's a really hard day. There were a few hard days, but really it was fun. But I'm thinking now I don't have it in me to do the travel. It's killing me. And I used to keep track of how many trips I took for MAVEN. I was curious over the lifetime. And then I realized it was 25 a year times the number of years, and so I stopped counting. But I'm figuring about 300 airplane trips. And I just passed United 2 million miles lifetime, for which they gave me 10 free drink coupons.
Hunker down.
Where's that one? I heard that word. Also, I'm going to be 60 this year. Well, I look 60. I'm really only 38. This is what being a PI does for you. If I were to start over on another mission, it's a minimum of a decade. And it's hard work. I think it's a younger person's game, Dave.
Any plans?
Is there anyone on your team where this is the entirety of their career as MAVEN? Like someone who came in as that graduate student who nailed the postdoc, who's now a junior research scientist?
We have people who did, the short answer is no, but we have people that have come close.
Okay.
People who did their PhD thesis on MAVEN-oriented research, but not under the auspices of MAVEN, and then are now postdocs or junior researchers working MAVEN. That's pretty close. We have a lot of people who have spent 12 years of their life on MAVEN. It'll be 12 years this fall since that conversation that I count as day one. And some of the science team were involved since then. Some of the Lockheed people got on board a year later, Goddard a year later than that. So, nobody's been working it longer than that. I would be afraid to count up the total number of person years that has gone into MAVEN. I know what we've paid for, and that is about 600 people, the equivalent of 600 people working full-time for 4 years. That's the effort that goes into building a mission like MAVEN. And that's independent of launch vehicle. And you can derive that number just by taking the cost of MAVEN and dividing by the average cost of a person. To pay a person. To pay their salary and overhead and
We're
benefits.
academics for bought and sold, we know it.
Back to that strip club. It's not very exhilarating. You're much more relaxed this time around, I have to say. It's very interesting.
We're in orbit. We're taking data. It's working.
Like how there was tension. Now that I'm thinking about it, there was tension last time in these presentations, and sort of like, oh, this is going to happen. We have to get off the ground. It's great. It's awesome. I love it.
I don't know how many talks I've given in the past where I said, this is what we're going to do. And it is so much fun to get up now and say, this is what we've done and what we're doing now. It's a very different talk, even though a third of the charts are the same ones. It's fun.
Yeah.
Can you tell I'm excited?
Fun for all of us, too.
Would you nominally be backup communications for the 2020 rover if you're still out there? Could this be a way to argue for extensions?
Yes and no. It's not just nominally. We are the comm relay for the 2020 rover.
Okay.
There is no realistic expectation that MRO and Odyssey will still be operating, and the U.S. isn't launching another orbiter. So NASA has a vested interest in ensuring that we survive that long. They manifest it most closely by tracking our fuel usage and predicted fuel usage to make sure we don't use it all up now, but we can survive out that long. And there are ways of how we utilize it, and I can go into it if you want, that would have us surviving a decade or longer. However, at the same time, the way NASA does extended missions, they have the ability to fund the orbiter operations without funding the science.
Yeah.
We still have to argue for good science.
It's the ESA problem, where they fund only the mission and not any of the science, and so they have to beg for money elsewhere.
Yeah. I'll take your word for it. I don't know on my own.
I work on both sides, don't do that.
So in a sense, you could be using that fuel rather than extending your mission until 2020 to be doing even deeper dip campaigns and stuff that would be very...
We wouldn't... I'll give you the story. It'll take me a couple of minutes. First, we wouldn't do a deeper deep dip because if we go to a much higher pressure or density level, it causes problems for the instruments. In particular, some of them would suffer high voltage arcing that would damage them. That's how we chose the density at which we do the deep dip to. The way we bookkeep fuel usage, we had enough to ensure that we could do our primary mission. And that included something like 105 meters per second, or kilograms, I forget what unit, but a bunch of fuel to recover from an off-nominal orbit insertion. We didn't have an off-nominal, so all that fuel rolls over to extended mission. We have enough fuel to do our primary mission, which includes 5 deep dip campaigns, then an extended mission for N months, where N is what we move around depending on how the fuel usage is going. And then we raise periapsis so we don't have fuel usage to control our density corridor, and then can continue for another 6 years. Right now, N is running around, the last number I heard is 34 months, but it's going to be updated next week significantly, and I haven't seen that number. It was in my email, and I didn't read it on the plane.
As much as 34.
Yeah. Now, if we do additional deep dips beyond those 5, each deep dip we do costs us the equivalent of 2 months worth of fuel. So my belief is that fuel is mine to use as long as we raise periapsis at a time where we have enough fuel to survive for 2020. But, you know, do I want to...
You can't go outside anymore. We need to keep you in bed to be an organ donor later. Yes.
So I don't know if you can answer this. Am I understanding correctly that the science MAVEN can do is being limited by the need to keep it around
No.
for mission?
No.
Okay,
I would never put it that way, and I don't think that's true.
okay.
First, and I want to be careful how I say this because I want to be clear. We proposed a primary mission. Anything beyond that is gravy.
Okay.
And tomorrow I'll talk a little bit about an extended mission. I don't want to talk about it tonight. Beyond that, we could run an extended mission based on fuel for about 3 years. If we'd never raised a periapsis in order to survive longer, we would only go about a few more months after that. So we're not cutting short our mission very much in order to survive out a decade. Plus, once we raise periapsis, we actually still continue to meet our threshold level 1 requirements. That is, we're still a viable, credible science mission. We lose a few things, but we keep a lot more. So there are trade-offs. Every time we're doing communications relay, and we've tested it. We haven't actually been asked to do it, but we've tested it on orbit. Every time we do that, we're not doing our science. But I'm a believer in the program, and I'm happy to do our part as long as we get to do our science.
It's that second part that I was concerned about for a moment, so I'm glad to hear that.
There are places along the path to get here where I've been concerned.
Yeah.
Today, I'm much less concerned. I think we're going to be doing science for the next decade, if things don't fail.
And there could be another comet.
You know, when we submitted our proposal, we have to put a list of the top risks. If we had put Comet, we would have been laughed out of the room. Stephen, you had a...
I was going to point out, is this true that this is a unique situation for you, this push-pull between comm relay and science? Because all the other orbiters have been Mars, including JPL, NASA program missions, not at the island.
Yeah, this is the first one, and they have a lot of lessons learned about doing comm relay from a PI-led mission. It's really a difficult tightrope to walk.
So for the 2020 comm relay, can you do the comm relay in your elliptical orbit, or do you have to circularize to?
We haven't done any analysis for 2020. We have done an analysis for Curiosity, because that's the one that's there, and that's the one where we're most likely to be asked to do relay over the next few years, that and InSight. And what I understood from the analysis I've seen is that in our current orbit, we're actually pretty good. That there are days where we can't even see it. So we can't do a relay every day like MRO. But on average, we meet the data throughput requirements for MSL. We could circularize our orbit, but that comes with a pretty steep penalty on fuel usage, either to circularize or to control aerobraking, and consequent effects on longevity. And it really doesn't improve us that much. It would be, at best, a factor of 2 improvement, and it would kill our science completely. So I think that it's a bad philosophy to kill one area to have incremental improvement in a different area. But I don't get to make that decision. I get to argue. And I think it's likely the decision has been made not to have us circularize in practice, if not on paper.
Where does that decision get made in the hierarchy of NASA?
I don't know. I have discussions with Fook Lee, who's the program office manager at JPL, and Jim Watson now, the Mars program director at headquarters, Jim Green at headquarters. I think if there was a decision that was going to impact us, it would be made at a higher level than that, but I don't know.
What's the meaning of periapsis?
I'm sorry, that's the lowest altitude in the orbit. So we're in an elliptical orbit. Let me go back to that chart. This is our orbit relative to Mars to scale, and periapsis is the lowest point. We average about 150 kilometers above the surface. Apoapsis is the highest point, and we average about 6,200 kilometers above the surface.
Once you raise the periapsis to be in your sort of station-keeping orbit, does the precession essentially stop?
No, because we don't raise it that much. We raise it from 150 kilometers lowest point to about 200 or 210. What we need to do, the periapsis on its own just goes up and down, driven by the gravitational field and the topography. And we need to get it high enough so that in doing that, it doesn't dip down to a low enough altitude that it affects the spacecraft. What we're doing now is we want to keep it within a density corridor between 0.05 and 0.15 kilograms per cubic kilometer, one of the more common units of density. And as it wanders up and down, we have to keep doing orbital trim maneuvers in order to keep it within that corridor. And that's the biggest fuel usage we have.
And what's the purpose of trying to keep it right in that corridor?
That's as deep as we want to go during regular mapping. If we go deeper, we run the risk of losing control authority over the spacecraft. But we want to go as deep as we can. And if we're too shallow, we're above what's called the exobase, which is the altitude from which things escape. So this is just the best balance between science at one end and safety at the other end. And early on, we did analyses to figure out what that balance was. What represented the best science, what represented the best safety, and how do we pick a range of densities. When we do our deep dips, we lower periapsis to go to deeper densities, and there, instead of between 0.05 and 0.15, we're between 2 and 3.5 kilograms per cubic kilometer, and it's the same thing of balancing science and safety that push us in different directions.
All right, any more questions for Bruce?
So tomorrow we'll talk about science, which is more fun in many ways. It's what it's about. Thank you.
Thank you.